Imagine a world without a sky. A world where the sun is not a fiery ball, but a gentle, shimmering light. This light dances on the surface far above you, like a million tiny diamonds scattered on a blue silk sheet. You are floating, weightless, in an endless expanse of blue. There is no ground beneath your feet, only a deeper, darker shade of the same color, stretching down into mystery. The air you breathe is not air at all. It is the very water that surrounds you, cradling you in its cool, gentle embrace. Around you, life moves with a grace and silence that is almost dreamlike. This is not another planet. This is our own world, a part of it that most of us will never see with our own eyes. It is the ocean, a realm of wonder and secrets. The only sounds you hear are the soft crackle and pop of tiny creatures nearby, and the distant, haunting song of a whale calling to its family across miles of open water. The silence is not empty. It is full of life, full of stories waiting to be told. Schools of silverfish flash past you like a living river, their scales catching the fading sunlight in a breathtaking display of coordinated movement. They move as one, a single organism with 1,000 eyes, turning and twisting in perfect harmony. Below them, a garden of coral stretches out, not green like the gardens on land, but a riot of pinks, purples, oranges. It is a city built by tiny animals, bustling with activity, yet appearing perfectly still from a distance. This is a place of profound peace, but also of constant, hidden drama. Every creature here is part of a delicate dance of survival. A small, colorful fish peeks out from its coral home, its eyes wide and watchful. It is looking for food, but it is also trying not to become food itself. A shadow passes overhead, large and fleeting, and the small fish darts back into the safety of the coral branches. The hunter moves on, its sleek body cutting through the water with effortless power. This is a world of both breathtaking beauty and stark reality, where life and death are intertwined in every moment. It is a world that has existed long before us, operating by its own ancient rules. We often think of our planet as the land we walk on, the cities we build, and the forests we explore. Yet more than 70% of our world is covered by this vast blue wilderness. It is the true heart of our planet, a massive living system that regulates our climate, produces the oxygen we breathe, and holds an incredible diversity of life that we are only just beginning to understand. For the next 60 minutes, we will leave our world behind. We will dive beneath the waves together to explore this hidden kingdom. We will journey from the sunlit shallows to the darkest depths to meet the extraordinary creatures that call this place home. It is a journey into the ocean you have never seen. The life we see on land, the birds, the mammals, the insects, is only a tiny fraction of the life on Earth. The vast majority of living space on our planet is not on the continents, but within the ocean. It is a three-dimensional world, stretching for miles in every direction, from the sunlit surface to the crushing blackness of the abyss. And in this immense volume, an incredible cast of creatures has evolved over millions of years. They have adapted to fill every possible niche, from the warmest tropical reefs to the freezing waters of the poles. Many of these animals are so strange, so wonderfully bizarre, that they seem like something from a fantasy novel. Yet they are real, living their lives in a world hidden from our everyday view. Think of the sheer scale of it. The average depth of the ocean is over 2 miles. In the darkest trenches, the pressure is more than 1,000 times what we experience on the surface. It is a pressure so intense it would crush a car as if it were a tin can. Yet, even here, life finds a way. Creatures with soft, gelatinous bodies drift in the darkness, creating their own light to attract prey or find a mate. They are the living lights of the deep, a silent, slow-motion firework display happening miles below our feet. These are not just a few oddities. They represent a massive, thriving ecosystem that dwarfs anything we know on land. The story of life on Earth is, in large part, the story of life in the ocean. On our journey, we will encounter this unseen majority. We will start in the shallows, where sunlight fuels vibrant coral reefs. These reefs are the ocean's great cities, teeming with millions of inhabitants. They are built by tiny animals called polyps, working together over thousands of years to create colossal structures visible even from space. Then, we will venture into the open ocean, the vast blue desert where giants roam. Here, we will meet the largest animal that has ever lived, the blue whale, and the intelligent and social dolphins that leap from the waves. This open water seems empty, but it is a highway for migrating animals and a hunting ground for some of the fastest predators on the planet. Our exploration will not stop there. We will continue our descent into the twilight zone, where sunlight fades to a permanent dusk. Here, animals have developed enormous eyes to capture the last photons of light. And finally, we will plunge into the midnight zone, a world of total blackness, cold, and immense pressure. This is the largest habitat on Earth, and it is filled with creatures that defy our imagination. We will meet fish with fishing rods growing from their heads and squids that are larger than a person. By meeting these creatures, we begin to understand the true scope of life and the incredible power of evolution to shape it in the most remarkable ways. This journey is a promise. It is a promise to show you a world that is both alien and deeply connected to our own. We will not just look at these creatures. We will seek to understand them. How do they survive in such extreme environments? How do they find food? How do they avoid becoming food themselves? How do they communicate? How do they find partners? How do they raise their young in a world so different from ours? These are the questions we will explore together. Our goal is to go beyond the simple facts and figures, to reveal the stories of these animals' lives. We want to share the wonder and the science in a way that everyone can understand and appreciate. We will learn that a fish is not just a fish. There are fish that can change their color in the blink of an eye to disappear against a coral background. There are fish that can change their sex, starting life as a female and becoming a male later on. There are even fish that can fly, gliding over the water's surface for hundreds of feet to escape a predator. Each species has a unique set of skills, a unique story of adaptation. We will tell these stories as a series of incredible tales from a hidden world. We will focus on the details that make each animal special. To bring these stories to life, we will use the most advanced filming technology. We will slow down time to witness the lightning-fast strike of a predator. We will speed it up to see the slow, patient growth of a coral reef over months. We will use special low-light cameras to penetrate the darkness of the deep sea and reveal the creatures that live there. The visuals will be paired with a rich soundscape. You will hear the clicks and whistles of a dolphin pod as they coordinate a hunt. You will hear the powerful rush of water as a humpback whale breaches. You will hear the gentle, rhythmic crunch of a parrotfish eating coral. Our promise is to make you feel as if you are there with us, floating in the blue. We will guide you through this underwater world section by section, building your knowledge step by step. We will start with the basics of the ocean environment itself, the different zones, the habitats. Then we will dive into the specific behaviors of the animals, how they hunt, how they hide, how they travel across vast oceans. Finally, we will look at their life cycles, from birth to reproduction, and discuss the challenges they face in a changing world. This structured journey will ensure that by the end of our hour together, you will have a clear and comprehensive picture of life beneath the waves. To truly understand the ocean, we must meet its inhabitants. Our journey will introduce you to a diverse cast of characters, each playing a vital role in this underwater drama. First, we will meet the foundation of it all: plankton. These are the tiny, often microscopic organisms that drift with the currents. They may be small, but their numbers are astronomical. Phytoplankton, the plant-like drifters, produce more than half of the oxygen in our atmosphere through photosynthesis. They are the grass of the sea, the base of the entire marine food web. Zooplankton, the animal-like drifters, feed on them, and are in turn eaten by larger creatures. Without plankton, the great whales and vast schools of fish simply could not exist. Next, we will introduce you to the architects of the ocean, the corals. These are not plants, but colonies of tiny animals that build hard skeletons around themselves. Over generations, these skeletons build up to form the massive, complex structures of a coral reef. We will tell the story of a single coral polyp, a tiny creature no bigger than a grain of rice, and show how its life contributes to building one of the largest living structures on Earth. We will see how the reef it helps build provides a home, a nursery, a hunting ground for thousands of other species, from the smallest shrimp to the largest sharks. They are the ultimate ecosystem engineers. Of course, no exploration of the ocean would be complete without the fish. We will showcase the incredible diversity of this group, from the majestic and powerful tuna to the strange and wonderful anglerfish. We will follow a school of sardines as they form a massive, swirling bait ball to defend against predators. We will observe the patient and clever grouper as it teams up with a moray eel to hunt, a rare example of cooperation between different species. Each fish has a story that reveals a unique solution to the challenges of underwater life. Finally, we will spend time with the ocean's charismatic megafauna, the marine mammals. We will swim alongside pods of dolphins, witnessing their intelligence, complex social bonds, and playful nature. We will listen to the complex, beautiful songs of humpback whales, which travel for thousands of miles across the ocean. We will meet the devoted sea otter mother, who cradles her pup on her belly while she floats on her back. These animals are often the most relatable to us. By sharing their stories, their family ties, their long migrations, their struggles to survive, we can build a powerful emotional connection to the wider ocean world they represent. They are the ambassadors of the sea. Section 5. Why this world matters. As we embark on this journey, ask a fundamental question. Why does this hidden world matter to us? Our fates are inextricably linked. The ocean is not just a distant, beautiful place. It is the life support system for our planet. It acts as a giant thermostat, absorbing and distributing heat around the globe, regulating our weather and climate. Currents flow like massive rivers, carrying nutrients, shaping weather patterns that affect farming and life on every continent. Without a healthy ocean, land climate would be far more extreme. The ocean is a source of the very air we breathe. We met phytoplankton. These tiny plants produce more than half the world's oxygen. Every other breath you take comes from the ocean. This has happened for billions of years, creating and maintaining the atmosphere that allowed complex life. The health of microscopic organisms ties directly to our atmosphere. A sick ocean means a sick planet, a threat to our survival, an invisible but essential connection. The ocean is also sustenance and livelihood for billions. Coastal communities depend on fish for protein. Fishing industries, tourism, shipping, these resources are not infinite. When we damage the ocean through pollution, overfishing, climate change, we harm wildlife and ourselves. This journey is more than a documentary. It's an exploration of our connection to the planet. Beauty, complexity, importance. The stories of these creatures remind us what's at stake. A mother whale teaching her calf to breach. A tiny clownfish tending eggs. We witness a global system we are part of, to foster wonder and responsibility. Protecting the ocean is protecting ourselves. Section 1. The Sunlit Zone. A world bathed in light. Our journey begins here, in the uppermost layer of the ocean, the sunlit zone. This realm, also known as the euphotic zone, stretches from the shimmering surface down to about 200 meters or 650 feet. It is the only part of the ocean where sunlight is strong enough to power photosynthesis. This single fact makes it the most productive and densely populated region in the entire marine world. The light that filters down from above is the engine that drives everything. It provides the energy for tiny plant-like organisms to grow, which in turn feed a cascade of larger and more complex life forms. This is the ocean's vibrant, bustling nursery and its busiest marketplace. Life here is a brilliant explosion of color, movement, and activity, all thanks to the power of the sun. The character of this zone changes dramatically with depth. Near the surface, the light is bright, and the water is warm, stirred by wind and waves. This constant motion mixes oxygen and nutrients, creating a perfect environment for life to thrive. Here you find the great floating forests of sargassum weed and leaping dolphins that seem to celebrate the sun. As you descend, the light begins to fade and the colors change. The vibrant reds and oranges are the first to be absorbed by the water, leaving a world dominated by blues and greens. The pressure increases with every meter, and the water becomes calmer, more still. Creatures that live deeper in this zone are adapted to a dimmer, cooler, and more stable world. This is the world we are most familiar with, the one we see in photographs and on holidays. It is home to the spectacular coral reefs, the lush seagrass beds, the dense kelp forests. A staggering 90% of all marine life is found within this sunlit zone. From the smallest shrimp to the largest sharks, almost every creature you can easily name finds its home here. Because there is so much life, there is also intense competition for food, for space, for mates, and with so many eyes, there is nowhere to hide for long. The brilliant light that gives life also exposes it. Predators and prey are locked in a constant evolutionary arms race, developing incredible camouflage, dazzling speed, and clever strategies to survive. Every moment in the sunlit zone is a balance between opportunity and danger. This bright, beautiful world is a battlefield as much as it is a paradise. Section 2. The Drifters, Lifeblood of the Ocean. Before we meet the larger inhabitants of the sunlit zone, we must first pay respect to its true rulers, the plankton. The word plankton comes from the Greek word for drifter or wanderer, and that is exactly what these organisms do. They are a vast community of plants, animals, and bacteria that drift with the ocean currents, unable to swim against them. They range in size from microscopic single-celled algae to larger jellyfish, but the vast majority are invisible to the naked eye. Despite their small size, their collective impact is monumental. They are the foundation of the entire marine food web. Without this drifting soup of life, the oceans as we know them would be empty. Plankton is broadly divided into two main groups. The first is phytoplankton, which are tiny, plant-like cells. Like plants on land, they use photosynthesis to convert sunlight into energy. In doing so, they produce a staggering amount of oxygen, more than all the rainforests on Earth combined. Every second breath you take is a gift from these microscopic ocean drifters. They are the grass of the sea, and their seasonal blooms can be so vast that they are visible from space, turning enormous patches of the ocean into a milky green or turquoise. These blooms are the single largest driver of life in the sea, a feast that kicks off a chain of feeding that extends all the way to the great whales. The second group is zooplankton, which are the animal drifters. This category includes a huge variety of creatures. Many are the permanent, lifelong members of the plankton community, such as tiny crustaceans called copepods, which are possibly the most numerous animals on the planet. Others are temporary visitors, the larval stages of much larger animals. The tiny, transparent babies of crabs, barnacles, sea stars, and fish spend their early days drifting as zooplankton. They feed on the even smaller phytoplankton, growing until they are large enough to settle on the seafloor or swim freely. The ocean's currents serve as their distribution network, carrying these young animals to new territories where they can begin their adult lives. This drifting world is a place of immense and constant predation. A single drop of seawater can contain thousands of these organisms, all eating and being eaten. Zooplankton graze upon the phytoplankton with relentless efficiency. In turn, they become the primary food source for countless larger animals, from small fish, corals, manta rays, to whale sharks. This constant transfer of energy, from the sun to phytoplankton to zooplankton, and then up the food chain, is what fuels the entire ocean ecosystem. These humble, invisible drifters are the quiet, unsung heroes that make all other ocean life possible. Their existence is a vital link connecting the sun's energy to every creature in the sea. Within the warm, clear waters of the sunlit zone, we find one of nature's greatest marvels, the coral reef. At first glance, a reef looks like a fantastic underwater garden, filled with strange, rock-like plants in every imaginable color and shape. But these are not plants. They are, in fact, vast cities built by tiny animals. The master architects of these metropolises are small creatures called coral polyps. A single polyp is a simple, soft-bodied animal, closely related to a jellyfish or a sea anemone. It is often no bigger than a pencil eraser, with a ring of tiny tentacles for catching food. The secret to their city building lies in their ability to extract calcium carbonate from the seawater. Each individual coral polyp builds a hard, protective limestone cup around its soft body. This cup is its home and its skeleton. Most corals are colonial, meaning thousands or even millions of these polyps live together. Their skeletons fused into one massive structure. As old polyps die and new ones build on top of them, the colony grows, expanding over centuries and millennia. Generation after generation, this slow and patient process creates the colossal, complex formations we know as coral reefs. Some of the reefs on our planet today began growing over 500,000 years ago. They are living monuments of time, the largest structures ever built by any animal, including humans, and are even visible from space. The success of these animal architects depends on a crucial partnership. Living within the tissues of most reef-building coral polyps are microscopic algae called zooxanthellae. This is a symbiotic relationship, a pact of mutual survival. The coral polyp provides the algae with a safe home and the compounds they need for photosynthesis. In return, the algae use sunlight to produce energy, and they pass on up to 90% of this energy to their coral host. This extra food allows the corals to grow faster and build their massive skeletons. It is this partnership that fuels the construction of the reef, and it is the algae that give corals their spectacular range of colors: brilliant reds, purples, fluorescent greens, and yellows. Without this partnership, the reef cannot survive. If the water becomes too warm, the corals become stressed and expel their algal partners. This is a process known as coral bleaching. Without the algae, the coral's tissues become transparent, revealing the white limestone skeleton beneath. The coral is not yet dead, but it is starving and vulnerable. If conditions do not improve quickly, the coral will die, leaving behind a barren white skeleton. A bleached reef is a ghost town, a silent, colorless reminder of a once vibrant city. The health of these tiny architects and their minuscule partners is a sensitive indicator of the health of the entire ocean. As the sun climbs high in the sky, the coral city awakens into a frenzy of activity. The light illuminates every corner of the reef, and its residents emerge to begin their daily routines. The reef is a mosaic of different neighborhoods, each with its own character. Towering pillar corals provide high-rise apartments for damselfish. Broad table corals offer shady overhangs where larger fish can rest. Intricate branching corals create a dense, thorny thicket, a perfect sanctuary for tiny, vulnerable creatures to hide. Predators now patrol the open water between the coral heads. Every inch of this complex structure is utilized. Competition for space in this crowded metropolis. The daytime is rush hour on the reef. Huge schools of fish move in coordinated swarms, their synchronized movements a defense against predators. Parrotfish, with their powerful beak-like mouths, scrape algae off the surface of the corals. As they do, they crunch up the coral skeleton itself, excreting it later as fine, white sand. Meanwhile, cleaner wrasses set up cleaning stations at prominent coral heads. Larger fish, including barracudas and groupers, queue up patiently. Cleaner wrasses pick parasites and dead skin, even inside mouths. It is a remarkable truce, a vital health service in the heart of the city. This is also a time for hunting. A moray eel pokes its head out from a crevice, its mouth agape. It waits for an unsuspecting victim to swim too close to its lair. On the sandy flats between coral patches, a stingray glides silently, flapping its pectoral fins like wings. It uses electroreceptors in its snout to detect the faint electrical fields of small crustaceans and worms, then excavates them with a powerful jet of water from its mouth. The daytime reef is a sensory explosion. Shapes, colors, patterns. But it is not a silent world. If you listen closely, you can hear the constant noise of the reef. clicks, croaks, grunts, snaps. Most of this sound comes from the snapping shrimp, which creates a loud pop by closing its specialized claw at incredible speed. This sound is used to stun prey and communicate. Added to this is the crunching of the parrotfish and the low-frequency grunts of groupers. The reef is a symphony of life, a noisy, bustling, and wonderfully chaotic city operating at full tilt under the tropical sun. As the sun sets, a profound transformation sweeps across the reef. The sun dips, colors flatten, the reef silhouette sharpens. The changing light triggers a massive shift change, one of the most dramatic and predictable events in the ocean. The creatures of the day, the brightly colored fish that filled the water column, now seek shelter for the night. Parrotfish secrete a protective mucus cocoon around themselves to mask their scent from nocturnal hunters. Small damselfish retreat deep into the protective branches of the coral. Butterfly fish retreat deep into the protective branches of the coral. The daytime bustle fades, and for a brief period during twilight, an eerie calm descends upon the reef. But this peace is short-lived. As darkness falls completely, a new cast of characters emerges from the shadows. The night shift takes over. The coral polyps themselves, mostly retracted during the day, now extend their delicate tentacles to feed. From a distance, the entire surface of the reef seems to become fuzzy, as millions of tiny mouths open to catch the zooplankton that rises from the depths under the cover of darkness. Many of the reef's most formidable predators are nocturnal. While the day shift hunters relied on sight, the night hunters often use other senses. Sharks, with their exceptional sense of smell and ability to detect electrical fields, glide silently through the darkened corridors of the reef. Octopuses pour their soft bodies out of tiny crevices where they spent the day hiding and begin to crawl across the coral, their long arms probing every hole for a sleeping fish or an unwary crab. The reef at night is also a world of strange and beautiful light. Bioluminescence, the production of light by living organisms, is common here. A passing predator can trigger a chain reaction of flashes from tiny organisms in the water, outlining its shape in a ghostly light. Cuttlefish can produce shimmering, hypnotic patterns on their skin to confuse prey or communicate with mates. Even the worms that live within the reef can glow. This living light serves many purposes: to startle predators, to lure prey, or to signal a potential partner. The Coral City at night is a completely different world. A darker, quieter, and more mysterious place, ruled by different senses and a new set of ancient rhythms. Leaving the crowded, vibrant metropolis of the reef behind, we now venture out into the open ocean. This is the pelagic zone, the vast, three-dimensional expanse of water that lies beyond the continental shelves. It is by far the largest habitat on Earth, a seemingly endless world of blue. From the surface, it can appear empty, almost like a desert. There are no trees, no mountains, no structures to hide behind. There is only the surface above and the deep, dark blue below. For the creatures that live here, there is no solid ground to rest on, no burrow to retreat into. They must spend their entire lives swimming, drifting, or floating in this immense void. Life in this blue desert is sparse compared to the coastal zones because nutrients are much harder to come by. Without a nearby seafloor to recycle dead organic matter, the essential building blocks for life are scarce. The base of the food web here, just as everywhere else, is phytoplankton. But these tiny plants can only grow in the sunlit surface layers. Their populations are spread thinly across immense distances. This means that food for everyone else is patchy and unpredictable. The animals that thrive here are those that are built for travel, built for efficiency, built for opportunism. They are masters of covering vast distances in search of their next meal. The key to survival in the open ocean is movement. This is a world of nomads and long-distance travelers. Many species, from tiny zooplankton to the great whales, undertake epic migrations, following the seasonal blooms of food across entire ocean basins. Tunas, built like torpedoes, can swim at incredible speeds for thousands of miles. Sea turtles navigate with an unerring sense of direction, back to the very beaches where they were born. These journeys are among the most remarkable feats of endurance in the animal kingdom. Because there is nowhere to hide, creatures of the open ocean have developed unique forms of camouflage. The most common is countershading. Animals like sharks, dolphins, and tuna have a dark back and a light belly. When seen from above, their dark back blends in with the deep blue of the abyss below. When seen from below, their light belly blends in with the bright, shimmering surface. Other creatures, like many jellyfish and larval fish, are almost completely transparent, becoming nearly invisible ghosts in the water column. In the Great Blue Desert, the best way to survive is to simply disappear. The vast emptiness of the open ocean is the only habitat large enough to support the biggest animals that have ever lived, the great whales. And the largest of them all is the blue whale. Reaching up to 30 meters or nearly 100 feet in length and weighing almost 200 tons, the blue whale is a true giant. Its heart is the size of a small car, and its tongue alone weighs as much as an elephant. To witness such an animal rising from the depths is to witness the sheer scale and grandeur of life in the sea. These magnificent creatures are baleen whales, which means instead of teeth, they have long plates of baleen hanging from their upper jaw, which they use as a giant sieve. Despite their colossal size, blue whales feed on some of the smallest creatures in the sea. Krill, a type of small, shrimp-like zooplankton. To eat, a blue whale lunges forward, opening its enormous mouth and taking in a huge gulp of water and krill, a volume of water larger than its own body. It then uses its massive tongue to force the water out through its baleen plates, trapping thousands of krill inside. A single blue whale can consume up to 4 tons of krill in a single day. To find these dense swarms of food, they must travel immense distances, migrating from their cold water feeding grounds near the poles to their warm water breeding grounds near the equator. The open ocean is also the domain of the toothed whales, which include dolphins, orcas, and the mighty sperm whale. The sperm whale is the largest toothed predator on Earth, a specialist hunter of the deep. It can dive to depths of 2,000 meters, more than a mile down, holding its breath for up to 90 minutes. In the pitch-black abyss, it hunts for giant squid. The scars from squid tentacles, often seen on the heads of sperm whales, are testament to the epic battles that take place in the deep. It finds its prey using echolocation, emitting a series of powerful clicks and listening for the echoes that bounce back. These clicks are the loudest sounds produced by any animal, powerful enough to stun their prey at close range. Whales also have rich and complex social lives. Dolphins live in large, fluid groups called pods, where they communicate using a vast repertoire of clicks, whistles, and body language. They cooperate to hunt, surrounding schools of fish and herding them into tight balls. Humpback whales are famous for their songs, long, complex sequences of moans, cries, and groans. All the males in a single population will sing the same song, which changes slowly over time. These songs can travel for hundreds of miles through the water, a hauntingly beautiful broadcast that connects individuals across the vastness of their ocean home. In the exposed environment of the open ocean, hunting is often a game of pure speed. With a sleek, torpedo-shaped body and a powerful, crescent-shaped tail, the tuna is built for high-performance swimming. Unlike most fish, which are cold-blooded, some species of tuna are partially warm-blooded. A special network of blood vessels allows them to keep their swimming muscles and brain warmer than the surrounding water. Tuna are relentless pursuit predators. They travel in schools, constantly roaming the open ocean in search of smaller fish like mackerel and sardines. When a school of prey is located, the hunt begins. Their pursuit is powered by an immense metabolism. They must eat up to a quarter of their body weight each day just to fuel their high-energy lifestyle. Another master of open ocean hunting is the sailfish. Famous for its enormous dorsal fin, which can be taller than the fish's body is long, the sailfish is arguably the fastest fish in the ocean, clocked at speeds approaching 70 miles per hour. They often hunt cooperatively. A group of sailfish will use their large sails to herd a school of fish or squid into a tight, swirling ball near the surface. The sails, which can flash with changing colors, may help to confuse the prey and coordinate the attack among the hunters. Once the prey is contained, the sailfish take turns dashing in, using their long spear-like bill to slash and stun individual fish before swallowing them. Not all hunters here rely on speed alone. The oceanic white-tip shark is a master of opportunistic scavenging and stealth. It is a patient and persistent cruiser of the upper layers of the open ocean, often accompanied by pilot fish that swim close to its body. With its long, wing-like pectoral fins, it glides through the water with minimal effort, conserving energy as it searches for any potential meal. It is notoriously inquisitive and bold, often the first to arrive at a potential food source, such as a whale carcass. Its strategy is not to outrun its prey, but to outlast the emptiness of the blue desert, ever ready to capitalize on any opportunity that presents itself in this vast and challenging environment. As we leave the sunlit surface waters behind and continue our descent, we enter a new and mysterious realm, the mesopelagic, the twilight zone. This layer begins where the sunlit zone ends at around 200 meters and extends down to about 1,000 meters. Here the sunlight is faint, a permanent deep blue dusk. There is not enough light for photosynthesis. No plants can grow here. The temperature drops significantly, and the pressure begins to build to immense levels. A cold, dim, alien world caught between light above and blackness below. The creatures here are adapted to low light and scarce food. Food is limited to what sinks from above, a slow, constant rain called marine snow, or to what can be caught as it drifts through. Life here operates at a slower, more deliberate pace. To survive, animals have evolved extraordinary eyes. Many, like the hatchetfish, have large tubular eyes fixed upward. These eyes are extremely sensitive, collecting faint, downward filtering sunlight. They act like telescopes, spotting silhouettes of prey above. Other creatures, like the glass squid, have one eye much larger than the other. It uses the large eye to look up for shadows, the small eye to watch for bioluminescent flashes below. This is a world of shadows and silhouettes. Camouflage is critical, but many take camouflage further. Species like the hatchetfish and many types of squid have light-producing organs called photophores on their bellies. They can control brightness to match the faint sunlight above. This strategy, counter-illumination, erases their silhouette from below. One of the most significant events in the entire ocean happens every single day, centered on the twilight zone. It is the Deal vertical migration, the largest migration of animals on our planet in terms of sheer biomass. As the sun sets, a vast army of creatures begins a journey from the relative safety of the deep, dark waters up toward the surface. Trillions of zooplankton, squid, and small fish that spend their days hiding in the dim light of the twilight zone, between 200 and 1,000 meters deep. The reason for this enormous daily commute is simple: food. The sunlit surface waters are where the phytoplankton grow, and where the concentration of food is richest. By feeding at the surface only at night, these smaller animals can feast in the productive zone while avoiding the many visual predators, like tunas and seabirds, that hunt there during the day. As the sun rises, the migration reverses. The same trillions of animals descend back into the darkness, returning to the safety of the twilight zone before the daylight exposes them. This migration is a planetary rhythm, a heartbeat that pulses through the ocean every 24 hours, driven by the rising and setting of the sun. The vertical migration is also a critical process for the entire planet. As these animals feed near the surface and then return to the depths, they transport enormous amounts of carbon from the upper ocean to the deep ocean. When they respire in the deep, or excrete waste in the deep, or when they are eaten by deeper-dwelling predators, that carbon is effectively sequestered away from the atmosphere for hundreds or even thousands of years. This process, known as the biological carbon pump, plays a vital role in regulating our planet's climate. Below 1,000 meters or 3,300 feet, we enter the final and largest realm of the ocean, the aphotic zone, also known as the midnight zone. Here, there is no sunlight at all. The water temperature is near freezing, often just a few degrees above the freezing point of salt water. and the pressure is immense, increasing by 1 atmosphere for every 10 meters of descent. At these depths, the pressure can exceed 1,000 times that at the surface, a crushing force that would instantly destroy any land animal or unprotected submarine. This entire region, which includes the bathyal, abyssal, and hadal zones, constitutes the largest single habitat on Earth, containing over 90% of the living space on our planet. Yet, it is also the least explored. Life here is pushed to its absolute limits. Food is extremely scarce, consisting almost entirely of the marine snow that drifts down from the productive zones miles above, or the occasional large carcass, a whale, a great shark, that sinks to the bottom. In this cold, dark, high-pressure world, life is slow, strange, and incredibly efficient. Because there is no light to see by, many species have lost their eyes altogether, or have eyes that are tiny and likely non-functional. Colors are meaningless here, so most animals are a uniform black, red, or transparent. Bodies are often gelatinous, watery, with minimal skeletons and minimal muscles. This helps them to withstand the crushing pressure and conserves energy in a world where the next meal might be weeks or months away. Metabolisms here are incredibly slow. To cope with this, many have evolved enormous mouths and expandable stomachs, allowing them to swallow prey that is even larger than they are. Finding a meal is such a rare event that they must be able to take full advantage of any opportunity, no matter how large. Finding a mate is an even greater challenge in this vast, dark emptiness. This has led to some of the most bizarre reproductive strategies on the planet, including males that are tiny parasites, permanently fused to the bodies of the much larger females, ensuring they are always available when it is time to reproduce. The extreme conditions of the midnight zone have given rise to some of the most famously strange and seemingly monstrous creatures on our planet. Among the most iconic is the deep-sea anglerfish. The female anglerfish has a modified spine that extends from her head, at the end of which is a fleshy bulb. This bulb contains bioluminescent bacteria, and the anglerfish can control this light, making it glow and pulse in the darkness. She uses this built-in fishing rod and lure to attract small fish and crustaceans, dangling it just in front of her enormous, fang-filled mouth. When an unsuspecting victim, mesmerized by the strange light, swims in for a closer look, the anglerfish strikes with astonishing speed. Her jaw can open incredibly wide, and her body can distend, allowing her to swallow prey more than twice her own size. But perhaps the most bizarre aspect of the anglerfish is its reproductive life. The male is tiny, often less than 1/100th the size of the female. His sole purpose is to find a female in the vast darkness. He does this by following her unique pheromone trail. Once he finds her, he bites onto her body, and his tissues fuse with hers, becoming a permanent parasite. Another master of the big gulp is the gulper eel, also known as the pelican eel. This creature is less a fish and more a giant, swimming mouth. Its most prominent feature is its enormous, loosely hinged jaw, which is much larger than its own body. When it encounters prey, it can open its mouth into a huge, net-like scoop to engulf its meal, along with a large amount of water, which it then expels through its gills. It drifts slowly through the abyss, its tiny eyes offering little help, likely relying on vibrations in the water to detect the presence of shrimp or small fish. These creatures, which might seem like monsters from a nightmare, are in fact perfect examples of evolutionary efficiency. In a world where energy is the most precious commodity, they have adopted a sight and wait strategy. They expend almost no energy on movement, drifting passively until a meal comes to them. They are not monsters. They are survivors of the highest order, beautifully and bizarrely adapted to one of the most challenging environments on Earth. The ocean is far from a silent world. It is filled with a constant symphony of sounds, from the crackle of snapping shrimp to the booming calls of the great whales. Sound travels exceptionally well in water, making it the perfect medium for communication across vast distances. The clicks, whistles, and groans produced by marine animals, are not just random noises. They are a rich and complex language that carries vital information about identity, location, and intent. The noisiest places in the ocean are often the coral reefs. Listen to a healthy reef with a hydrophone, and you'd hear a constant crackling fizz, like bacon frying. Most of that noise comes from snapping shrimp. They produce a loud snap by closing a specialized claw at incredible speed. The claw movement creates a tiny, high-pressure bubble that collapses with a sharp report. The sound is used to stun prey, deter predators, and communicate. Millions of shrimp together create an ambient noise that masks other sounds. The masters of marine acoustics are the whales. Humpback whales are famous for their long, complex songs. The songs are structured with repeating themes and phrases, almost like human music. All males in a population sing the same song, but the song evolves over time. New elements added, old ones dropped. These songs can travel for hundreds of miles. They broadcast to attract females and to advertise a male's fitness and location to other males. Toothed whales, dolphins, and sperm whales use sound for echolocation. They produce high-frequency clicks, focused into a beam by the melon. Clicks travel out and bounce off objects. The whale listens for echoes and interprets time delay and direction. From that, it builds a detailed three-dimensional sound picture of its surroundings. This lets them navigate and hunt in complete darkness to find a fish hiding in a crevice or a squid in the abyss. For these animals, sound is vision. The challenges of life in the ocean have driven the evolution of remarkable intelligence in a wide range of creatures. Intelligence is more than just instinct. It is the ability to learn, to remember, to solve new problems, and to adapt one's behavior based on experience. We have already seen this in the complex, cooperative hunting strategies of orcas and dolphins, and in the tactical use of mimicry by the mimic octopus. These are not rigid, programmed behaviors. They are flexible strategies that require awareness and decision-making. Tool use is often considered a key indicator of higher intelligence, and it is not limited to primates. The sea otter is a classic example of a marine tool user. It uses a rock as an anvil to crack open hard-shelled prey like clams and mussels. Some dolphins have also been observed using tools. In Shark Bay, Australia, a population of dolphins has learned to carry a cone-shaped sponge on their beaks while foraging on the seafloor, likely to protect themselves from sharp rocks and stinging creatures. This is not an instinctive behavior. It is learned by young otters who watch their mothers. The octopus, with its large, complex brain, is another of the ocean's great problem solvers. In laboratory settings, they have shown the ability to solve mazes, to open screw-top jars to get food, and to recognize and distinguish between different human keepers. They are notorious escape artists in aquariums, able to figure out complex locking mechanisms. There is even evidence that they learn by observation. In one experiment, an octopus that watched another octopus solve a puzzle was able to solve it much more quickly itself. This suggests a capacity for social learning that is surprising in a largely solitary animal. These examples challenge our human-centric view of intelligence. They show that complex cognitive abilities have evolved in vastly different kinds of brains, shaped by different evolutionary pressures. The intelligence of an octopus is an alien intelligence, evolved in a soft-bodied, eight-limbed creature of the sea. The intelligence of a whale is the intelligence of a highly social, acoustic being living in a three-dimensional world of water. By studying these problem solvers, we not only learn about their incredible abilities, but we also gain a deeper appreciation for the many different ways there are to be smart in this world. For every creature in the ocean, from the smallest plankton to the largest whale, life is driven by two fundamental imperatives: to survive and to reproduce. The drive to create the next generation is a powerful, universal force. It has shaped the bodies, behaviors, and life histories of every animal we have met on our journey. The strategies for success are incredibly diverse. This final act of our story is about this fundamental cycle of life, death, and renewal. It is about the ingenious, bizarre, and often beautiful ways that marine animals find a mate, reproduce, and ensure their legacy continues. But this act is also about the unprecedented challenges that now confront this ancient cycle. The ocean is changing, and it is changing faster than ever before in human history. The world we have explored, from the sunlit reefs to the dark abyss, is facing a suite of threats driven by human activity. A warming climate, plastic pollution, and overfishing are putting immense pressure on marine ecosystems. These changes are disrupting the delicate balance of reproduction and survival, threatening the very existence of many of the creatures we have come to know. Therefore, our journey through the world of marine reproduction must also be a journey into the reality of ocean conservation. We will explore the impacts of these threats, witnessing firsthand how they affect the lives of these animals. But this is not a story of despair. It is also a story of hope and resilience. We will meet the scientists and communities who are working to protect this vital world. We will see inspiring stories of recovery, proving that when we give the ocean a chance, it has a remarkable capacity to heal. This is the story of the future of the ocean, a future in which we all have a part to play. For many of the ocean's simpler creatures, reproduction is a game of chance, played on a massive scale. This strategy is known as broadcast spawning. It is used by a huge number of marine invertebrates, corals, clams, sea urchins, and many species of fish. These animals release their reproductive cells, known as gametes, directly into the water. Males release clouds of sperm. Females release clouds of eggs. In the vast swirling ocean, some of these eggs and sperm must find each other for fertilization. The odds are stacked against them. Currents can carry clouds far apart. Filter feeders and predators eat eggs and sperm. Broadcast spawners overcome this by sheer numbers. A single coral colony can release millions of eggs. A female cod can release over 5 million eggs. Even if 99.9% are lost, enough survive to carry the next generation. Timing is everything. If an animal spawns at the wrong time, its gametes are wasted. So many species synchronize their spawning with incredible precision. The mass coral spawning on the Great Barrier Reef is the most spectacular example. Once a year, after a full moon in late spring, hundreds of species across hundreds of miles spawn within hours. The water becomes a thick, pink soup of new life. The event is triggered by environmental cues: warming water, the moon phase, and time of day. This timing ensures same-species gametes meet, maximizing fertilization. It is a breathtaking, coordinated spectacle that underpins the reef's existence. In the crowded and competitive world of the coral reef, simply releasing gametes into the water is not always enough. For many fish, reproduction requires a more personal approach. It involves courtship, a series of behaviors and displays designed to attract a mate and persuade them of your quality. These courtship rituals can be elaborate, colorful, and beautiful. They are a dance of life, a way for an individual to prove its health, strength, and genetic fitness to a potential partner. Many reef fish use color as their primary tool of persuasion. During the breeding season, males of many species will develop brilliant, intense colors. A male parrotfish or wrasse will transform from its everyday attire into a dazzling display of iridescent blues, greens, and pinks. These colors are a signal of health and vigor. He will then perform a display, flaring his fins and swimming in an exaggerated dancing motion to catch the female's eye and show off his finery. For some, courtship involves more than just a visual display. It involves architecture. The male pufferfish of Japan performs one of the most remarkable feats of construction in the animal kingdom. To attract a female, this small fish spends weeks creating a large, intricate, circular pattern in the sand. Using just his fins, he plows the sand into a series of radiating ridges and valleys, creating a symmetrical masterpiece that can be over 6 feet in diameter. The female pufferfish will visit the nests of several males, inspecting their work. She is a discerning art critic. If she is impressed by the perfection and complexity of a male's circle, she will lay her eggs in the fine sand at its center. The male's creation is an extended phenotype, a signal of his endurance and dedication. A male who can spend weeks on this exhausting, non-stop construction project is proving that he is strong and persistent, qualities that will hopefully be passed on to his offspring. In the vast majority of the animal kingdom, if there is any parental care after the eggs are laid, it is the female who provides it. But the ocean has a few wonderful exceptions to this rule. The most famous and remarkable of these is the seahorse. In their world, it is the male who gets pregnant and gives birth. The process begins with a beautiful and graceful courtship dance. For several days, swimming side by side, changing colors, and intertwining their tails. This dance synchronizes their reproductive states and strengthens their bond. When the time is right, the female uses an organ called an ovipositor to transfer her unfertilized eggs into a special brood pouch on the male's abdomen. The male then fertilizes the eggs inside his pouch. This pouch is much more than just a simple pocket. It is a complex organ, similar in many ways to a mammalian uterus. The inner wall of the pouch becomes lined with a network of blood vessels that provide the developing eggs with oxygen and nutrients. The male seahorse will carry his developing young for a period of 2 to 4 weeks. During this pregnancy, he is vulnerable. The swollen pouch makes him a more obvious target for predators and makes it more difficult for him to swim and hide. When the time for birth arrives, the male undergoes a series of muscular contractions, much like a human mother in labor. Over a period of several hours, he forcefully ejects the tiny, fully formed baby seahorses from his pouch. These tiny babies are perfect replicas of their parents, and from the moment they are born, they are on their own. The father's role is complete. This extraordinary strategy ensures that the eggs are protected and provided with a stable, controlled environment in which to develop. It is a beautiful and profound demonstration of a father's love and a unique solution to the challenge of raising a family in the sea. For air-breathing marine reptiles like sea turtles, reproduction presents a fundamental problem. They live their lives in the water, but their eggs cannot survive submerged. They must be laid on land. This forces the female sea turtle to undertake a difficult and dangerous journey back to her ancestral shores. After migrating thousands of miles and mating at sea, a leatherback sea turtle or a green sea turtle is driven to return to the same beach where she was born. She usually arrives under cover of darkness, waiting for the high tide to help her up the beach. In the water, she's streamlined and graceful. On land, she becomes clumsy and heavy. She hauls herself with powerful front flippers, a slow, exhausting process that can take hours. She searches high on the beach, beyond the high tide. Once she has chosen her spot, the real work begins. Using her large front flippers, she excavates a body pit. With incredible dexterity, she uses small, cup-shaped rear flippers to dig a deep, flask-shaped chamber. The nest can be up to 1 meter deep. Depth protects the eggs from predators and from the sun's heat. She enters a trance-like state and lays around 100 leathery, golf ball-sized eggs. After she has finished laying, her work is still not done. She must now disguise the nest. Using rear flippers, she covers the egg chamber with sand. Then, front flippers fling sand to scatter it wide, hiding the nest from dogs, hiding the nest from crabs, hiding the nest from birds. The whole process is a marathon that can take all night. Exhausted, she drags herself back to the sea, leaving the clutch buried. She will never see her offspring. Her duty is done. For the sea turtle eggs buried deep in the sand, the ordeal is just beginning. Their fate is now in the hands of the environment. The temperature of the sand will determine their development time, and for most sea turtle species, it will also determine their sex. Warmer sand temperatures tend to produce females, while cooler temperatures produce males. This is known as temperature-dependent sex determination. As global temperatures rise, there is a serious concern that nests will produce fewer and fewer males, creating a dangerous imbalance that could threaten the future of turtle populations. After about 2 months of incubation, the baby turtles, or hatchlings, are ready to emerge. They use a special, temporary egg tooth on their snouts to break free from their shells. The hatching of the entire clutch is roughly synchronized, and the hatchlings will work together, climbing over each other to dig their way up through the sand. They usually wait until the sand cools in the evening before making their final push to the surface, as emerging at night provides some cover from predators. The moment they break through to the surface, a desperate race for survival begins. The beach, which was a safe incubator, is now a death trap. The tiny hatchlings, only a few inches long, must run the gauntlet of predators. Ghost crabs scuttle from their burrows to snatch them. Shorebirds descend from the sky to pick them off. The hatchlings have one instinct, one overwhelming drive to get to the water. They find their way by heading towards the brightest, lowest horizon, which, on a natural beach, is the open sea, reflecting the moonlight or starlight. This mad dash across the sand is one of the most perilous journeys in the natural world. Only a fraction of the hatchlings that emerge from the nest will make it to the water's edge. But their troubles are not over when they reach the waves. The shallow water is filled with predatory fish waiting for this predictable feast. The hatchlings must swim frantically, heading for the relative safety of the open ocean. Once there, they will spend their first years, often called the lost years, drifting in the ocean currents, feeding on plankton. The odds are astronomical. It is estimated that only 1 in 1,000 hatchlings will survive to adulthood to complete the cycle. For a vast number of marine animals, the individual that hatches from an egg looks nothing like its parents. It begins its life as a larva, a tiny, often transparent creature that drifts in the water column as part of the zooplankton. Crabs, barnacles, sea stars, corals. The journey from this simple larval form to the complex adult body plan is one of the most dramatic transformations in nature. Metamorphosis. Consider the life of a crab. The female crab releases her fertilized eggs. Eggs hatch into a tiny, spiky larva called a zoea. This creature has a long spine and large eyes, and it looks more like a bizarre alien than a crab. It sheds its exoskeleton several times, passing through different zoeal stages. After several weeks, it transforms into the megalopa. Megalopa looks like a cross between a lobster and a crab. Long abdomen, small claws. Stronger swimmer searching for habitat. Megalopa finds suitable seafloor habitat. Chemical cue from an adult crab or the texture of the right kind of sand. This triggers the final molt. Megalopa sheds its skin and emerges as a tiny juvenile crab. Juvenile tucks its larval abdomen under and walks sideways. Metamorphosis complete. Drifting planktonic life to bottom-dwelling existence. Larva uses food-rich surface waters and the seafloor for the adult. This larval strategy offers dispersal. Ocean currents carry larvae hundreds or even thousands of miles. This allows species to colonize new habitats far from parents. It also ensures genetic mixing between distant populations. The larval stage is a perilous one, with immense rates of predation. But for those that survive, it is a ticket to travel the world, and a key reason for the widespread success of so many marine invertebrates. For the largest animals in the ocean, the strategy is the polar opposite of broadcast spawning. Whales invest an immense amount of time and energy into a single calf. Their reproductive cycle is slow, and the bond between mother and calf is one of the strongest in the marine world. Many of the great baleen whales undertake epic migrations. Humpbacks, gray whales. These migrations head to special breeding and calving grounds. Warm waters, calm waters, shallow waters, like the lagoons of Mexico, the protected seas around Hawaii and Tonga. These are the great whale nurseries. They offer advantages: fewer orcas, calm surface for newborns, thin blubber calves learning to breathe and swim. However, these tropical waters are like a desert in terms of food for the mother. The great swarms of krill and small fish that she feeds on are only found in the cold, nutrient-rich waters of the polar regions. So, in the nursery, for several months, the mother fasts, living entirely off her own fat reserves. The mother's devotion to her calf is absolute. She provides it with incredibly rich milk, which helps it to grow at a phenomenal rate. A humpback calf can gain over 100 pounds a day. The mother is a patient and attentive teacher. She guides her calf, keeps it close to her body for protection, and communicates with it through a series of gentle grunts and nudges. She teaches it the essential skills of whale life, including how to breach and slap its tail. The calf's playful antics, leaping, rolling, splashing, help it develop muscle strength and coordination. After several months, when the calf is strong enough and has a thick layer of insulating blubber, the mother will lead it on its first great migration. It is an immense journey of thousands of miles back to the feeding grounds. The mother will continue to nurse and protect her calf for up to a year, ensuring it has the best possible chance of surviving to adulthood and one day making this journey for itself. Our 60-minute journey is coming to an end. We have traveled from the sunlit shallows to the darkest depths. We have met an extraordinary cast of characters: beauty, complexity, drama. We have seen how they hunt. We have seen how they hide. We have seen how they communicate. We have seen how they reproduce. But we have also seen the profound threats they now face from a world changing at an unprecedented rate. The story of the ocean is no longer just a natural history story. It is our story. Coral reefs, great whales, tiny plankton are now inextricably linked to the choices we make on land. The future of the ocean will be determined by our ability to transition to clean energy, reduce our consumption of single-use plastics, manage our fisheries sustainably. These are immense challenges, but they are not insurmountable. The solutions exist. We have the knowledge, the technology, and the ingenuity to change our course. What we need now is the collective will to act, The responsibility does not lie with governments and scientists alone. It is a shared responsibility that falls to each and every one of us. Every choice we make in our daily lives can be a small vote for a healthier ocean. This journey was a promise to show you the ocean you had never seen. The hope is that seeing it leads to understanding, and understanding leads to caring. The responsibility to protect this world now rests on our shoulders. Let the wonder we have shared inspire a new commitment. Let us listen to the call from the blue, for in protecting the ocean, we are ultimately protecting ourselves. The next chapter in the ocean's story has yet to be written, and we all have a role to play in writing it. The journey begins now.